Hey y'all, so today is kind of the last final class period that you guys have to work on this project. You guys have through Sunday to kind of turn it in, and that's a tentative goal. Ideally, it's like you should be able to get it done by there. I think a lot of you guys are at a point where that's pretty doable. Worst case scenario, you guys can turn in that final week of classes, but ideally just get it done beforehand. So the due date is this Sunday, the 10th at midnight. And so here's the stuff that you guys need to turn in. Hopefully you guys have all of this kind of done and you guys are kind of wrapping up the coding. And then the last thing that you should need to do is kind of create this video describing your final design solution. And this should be no longer than 5 minutes. That's kind of the cap on it. Now I recommend a couple of programs for you guys to do that. They're both browser-based. Screencastify is probably my #1 recommendation. It's really great, simple to use. You can just install it in your browser, especially if you're using Chrome. It's a piece of cake. The only thing there, the only limitation is that you can only record on the free version up to 5 minutes, which if you're only, if the limit is 5 minutes, then you're good. If you need to do one longer for any reason, Loom's another good one. You guys can check that out as well. Pretty similar to like what I use with this. You can have your screen video here of you talking if you need to like do any gestures or kind of do any things like that, or you don't necessarily need to include that. I'd love to see you guys, your faces, but not required, right? The main thing is that I want to be able to see these kind of pieces. So I want you to be able to talk about, hey, which project did you do? What does your design solution look like? Maybe walk me through and talk me through how the design solution works, what components are needed, and then going to your actual kind of code. What did you come up with? How is this your circuit kind of designed? And then how did you code it to make it work? And that's going to be the main thing. So here I'm going to give you guys an example of what I did for mine, and this is kind of what I'm looking for with your guys's as well. I'm going to try and keep it under 5 minutes as promised, and so I have here my little timer to kind of keep myself in check. So without any further ado, let's go ahead and get started. So the project that I chose for this one was the sun tracker. And this is essentially, I pictured it as like something that you could put on a solar panel or something to move that solar panel to always be facing the sun squarely, so you're maximizing that solar energy capture. So you essentially need a light sensor that should be programmed to perform the following functions. It should follow the sun or lamp as it moves across the sky. It needs to stop seeking the sun when the light level drops to a point where the sensors can no longer function, so on and so forth. So that's what I'm trying to do. This is the design that I came up with, right? Pretty straightforward. What I have is essentially you got this solar panel. It's got these two angled flaps on it. They're kind of out at like a little bit of an angle on either side of it. And within those flaps, kind of just slightly recessed, is a light sensor, right, on each one. So you got a left light sensor and a right light sensor, left and right. This is kind of the top view down here. And there's a servo motor that is attached to this base, and that servo motor allows the whole thing to pivot and face the sun, right? So if the sun's over here, it can face here, right? As the sun moves, hopefully it will follow the sun, right? Now the way that these light sensors work within this is that the sun is coming in at an angle, and because of the angle of this, if the sun's over here on the left, right, then this right sensor is going to be getting more light. So when the right sensor is getting more light and reading a higher light value, then the entire thing needs to turn to the left, right? When they're both, when it's facing the sun directly, then they should be equal. Here's kind of the opposite. The sun's to the right, the left light sensor is getting more, so the panel needs to rotate to the right. So that's the idea I came up with. I just wanted to include this because this flowchart was what I used a lot for my code of this system. So you kind of start the servo at neutral position, and you sense the light levels, and you basically ask, is there enough light for this thing to operate? That's one of the parameters of the design problem. If there is, if there's not, then you just kind of keep waiting. If there is, then you're asking, hey, are the light levels equal? If they are, then you just keep sensing. If they're not equal, then you ask, hey, is the right sensor or the left sensor greater? And then you need to turn kind of accordingly. Okay, so that was the idea that I had. And then I had a few variables. And here I need 2 light sensors, a servo motor, and then a variables I need a right light level, a left light level, and then the servo position itself is what I kind of figured that I would need. So this is the final kind of design solution that I came up with here. Kind of tuck that away for now. So this is what it looks like. I've got a light bulb here kind of to represent my sunshine, just so you guys can see the general position. Here's my servo motor. There's the left sensor and the right sensor. They're hooked up to A1 or A0 and A1. Servo is here on pin 10. And I'll go ahead and show you guys what it looks like in action, and then I'll kind of walk you guys through it. So here I have my sun, And then here are the light levels. So let's see, first of all, if I just turn on a little bit of light, you guys will see nothing happens with either one, right? We need to reach a certain level. And once we reach a certain light level, then it'll actually start moving, right? Once that minimum threshold value is met by one of these light sensors, and there it goes. So here you can see it's actually working. Now if I go ahead and reset that real quick, let's move this there. I'll hit the reset button. So let's say that the sun is right here. It's over on this side. Oh, is it not going to let me move that now? Oh, it's not going to let me move that. So let's not worry about that. So let's say that the sun is over here, right, on the left. Then what that means is that the sun is on the left, then this guy is going to get a greater light value. And you'll see that it'll actually move to the left, right? So it's moving there to the left towards the sun, right? And then as soon as those levels end up being equal within like a relatively similar threshold, right, then it should go ahead and stop. Right. So now that the light levels are equal, it's gone ahead and stopped. And then now let's say that the sun has moved over here. Right now this side's getting a little bit more, it's a little bit brighter. And so then the panel will start to move in that direction. And then let's say then that they equal out, right? Then it'll stop. It gets more over here, continues moving in that direction, and it moves slowly. Right, so that's the idea, is that this is something that it's a more of a controlled move. Now one of the nice things about this is that I've set it up so that it's all customizable, right? So the light levels, the range in which it can sense is customizable. So here I've got it with it plus or minus 2, right? But you can also set that to more or less. And same with the servo position. You can make it write faster and move faster, or move slower. You can adjust the delay to set the amount of time that it takes. And so that's that. Pretty straightforward. Nothing too crazy here. I've got it kind of in the serial monitor. It's printing those light levels. If you want to reference those, you can also turn those off in the comments. And that's that. Yeah, so here I just kind of attached my pins, did all that jazz, and there you go. So I know took a little bit longer than anticipated. If you guys' videos go over, that's fine. Practicing, rehearsing them is definitely a good idea, so that you feel confident in what you're talking about. I would love to hear you guys just talking about your overall design. What I really want to see is you guys talking about kind of your plan and how that fits. And then I do want to take a look at your code and kind of have you walk through like maybe any struggles or things that you guys noticed that were challenging. Mine really, this one was pretty straightforward. The biggest thing was just kind of figuring out these Boolean statements asking about the light level. You know, so if the right level's less than or equal to the left light level plus 2, and it's greater than or equal to the left light level minus 2. So that was my way of doing a plus or minus within like a range, which was kind of cool. So figuring out how that worked, and then kind of creating these other conditions to make it work. There's also some other interesting stuff where, you know, the servo position, this variable could get greater than 180 or less than 0, which was a problem. So I had to create this other thing where, hey, you're only doing this when it's greater than 0, you're only moving this one direction, or when it's less than 180, you're moving this other direction. And once you reach that, then you have to stop. Okay, so just trying to make it as complete of a final design as possible. So that's that. Hope you guys, hope everything's going well, and that you guys are excited about your designs. I'm excited to see what you guys came up with. And yeah, I'll see you guys next week for doing some fun engineering challenges. So should be exciting.